Hello, welcome to today's webinar. The topic today is generating wind loads on DOM with circular base using C# library. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software, for instance, the webinars, Dlubal website, newsletters, and so on. I will be the moderator today. And my three colleagues can introduce themselves.
Hi, I'm Doğukan Karataş and I'm a product engineer at Dlubal Software and I'm responsible for developing API and web services. Today I'm going to answer your questions in the chat.
Hello, my name is Jaroslav Brož and I'm the leader of a team which is responsible for the development of API and web service. And today I'll present you the content of the webinar.
Hello, my name is Frank Faustich. I am responsible for product engineering and quality management. And today I will answer your questions.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. For the participants who participate the first time, you can show or hide the control panel when you want to ask questions to us. Enter the question here and we will answer you. If you don't get an answer during the webinar because there are too many, you will get an email afterwards. The other way is to watch the entire webinar and then email questions to info@dlubal.com. Then I hand over the screen to Jaroslav and he can start with his presentation.
Okay, I'll start sharing of my screen. I'll just have a look. Okay, this one. I think you should see my presentation.
Yes.
Okay. Perfect. So I'll start. Thank you, Andreas, for the introduction. Here is the content of my presentation and also my webinar. During the first chapter, I'll be talking about what's web service and API. Then I'll show you how to quickly install our C# library plus first step with the using of our API. Then I'll talk you some basics for the windload according to the Eurocode, and then I'll show you how to do it programmatically so that you can develop your own tool which will generate the windload on the dome or the cylindrical structures. What's web service and what's API? The main motivation why we did it, we want to bring the power of RFM6 or RSTAP9 or R section beyond its graphical interface. That means the providing of easy way how you can create an application on top of our application, or that you can very easily plug our application to your chain of the application. So if you have some application where you are, let's say, generating the model and then you need to run the structural analysis, so the bridge between you can make with our web service so that you can use your application to generate the model and then our application for do the calculation and design and checks. Or also that you can build your own tool or your own application based on the results which you are getting from our application, like the internal forces or some results coming from the other kinds of the analysis. what's currently possible and what's accessible in web service. You have access to the geometrical data. You have access to the materials and the sections. You can create load and load cases. We will see it in my webinar in presentation. You can also do the supports, interact with the supports. You can also somehow interact with the application, that I mean with the running of the calculation or doing some selections. And also you are able to easily get the results of the calculation through the web service operations or web service calls. We created a few libraries and the functions to work with web service. I'll be talking about it later on. Here, what I would like to do is that I would like to present you how it works under the hood. That means how it works on the background. You can think about our solution as we have the something which is called the server. That's our application, and then you have your application, which is kind of the client, and then the client could be written in the .NET, C#, Python, Java, or any language which is capable to do the so-called request. That means that from your client application through some specific language, you are requesting the data, or requesting to do some operation, or requesting to get the data, and then the application is responding with some response, which means if you are asking the information about the node, then you are getting the information about the node. If you are requesting to start the calculation, then calculation is started, and at the end you receive the response if the calculation was successful, or that there are some issues which you need to tackle in your model, like the wrong supports or the missing load cases, and so on. Basically, that's the scheme. On the background, we used so-called SOAP, which is an abbreviation for Simple Object Access Protocol. It has some definition language, which you can simply see. You can have a look on the structure, and you can work directly with it. As I told you before, that you can use any language which is capable to do so-called web requests or for the easiness of the use, we created two libraries. The one library that's written in the Python, and it's so-called Python high-level library. It contains very easy way how you can work with web service. There are some classes and the functions which you may use to create the object and to interact with the object. That's for the Python. We had webinars in the past where we presented mainly these libraries. Today we are focused on the second library which we have. That's for C#. We have C# low-level library. That means that you need to do a few things more than in the case of the Python, but it's not so difficult, because we are providing ways or the tools how you can easily start with your development, so you don't need to afraid that it's difficult to use. No, it's very easy to use and easy to start with simple examples. Here there is two links which leads to the places where we published our library, or also that we have an extension for Visual Studio that you can install and download to easily start with your development. So the first one, that's NuGet package gallery, where you can easily download our libraries and use them in the code. Here it's an link to the marketplace for the Visual Studio, where you can download the template for the project, and then you can use it in the IDE which you are using for the development. That's our two sources of our libraries for the C#. And then if you are interested to know how it's done on the background, we have an public repository on the GitHub, which you may visit, and you can see the source code which we have for the libraries. Here I'll jump to the browser, and I will start to show you. Here it's an nuget.org, and here I can easily type Dlubal. If I'll do it here, I have three packages which are available. Today we'll be talking about the RFM. Here you can click on it, you can see it, and then you can also download it through some CLIs, through some commands, or there is also capability in the Visual Studio how to do it directly in the Visual Studio. So that was the first way how to use the library. The second one, that's in the marketplace for the Visual Studio. If I will do the same, I'll receive the similar result. That here are some templates which I can have a look on it, and I can download it. And then if I do the download and the installation, I can easily start with the Visual Studio new project directly with all the references set to our libraries with example of the code. And here lastly there is an link, and there is a view of the GitHub repository which we have here, and here are also the source code of our libraries. Mostly it's automatically generated based on the WSDL web service description language. Why I'm talking about it? Because that's the possibility. If you would like to, let's say, extend the library with some functions, or that you somehow enrich or enhance what we have, you may do so with simply cloning the repository, or that you can easily download as a zip and then use it as a normal Visual Studio project, where you can do the modifications or the extensions if that's needed. So I'll jump to the Visual Studio. Here there is a possibility under the extension. If I will click here, that's manage extension, and here I'll do exactly the same which I did today twice. Here I have an option to download the extension, so it will be applied after the closing of the Visual Studio. So here is starting the installer. Once installation is done, then I can quickly continue. So I'll wait a couple of seconds for the update. And then we'll start the fresh Visual Studio and work with it. Basically, we should be able to just start the compilation of the project and then receive the results. Okay. So it's done, and then I'll start the Visual Studio Code, and then I'll show you what you can do. So here, what I can do is starting with create a new project. I think you are familiar with the structure, and here I have the dozens of templates which I may use as an let's say the startup of my project. So here I'll just start typing the RFM. Here is an template, so I can just use it. So I'll start it like the name my tool for wind calculation, and then so location solution name okay. Then I'll push create, and now I have a project in Visual Studio. Here I have already the code, which is provided from us. It should be a simple cantilever beam in the RFM, and now I can just build a solution, and then I'll just check a few things in my RFM, because here in the options, program options, here as an item, web service start the server automatically with the application by default is off. I have it already on, so you can also start it with the apply, and here I have an port ranges. It's important to say it, because here is an port range, and if I'll go back here, then I'll use it as an endpoint. That means the address where the application is listening. It's an local host, and this is the number of the application port. So I have it on, and here I think that if I will just run it, then I'll be connected to the application which I'm running. It's an version plus the language, and on the background, new model with the name my test model is created. There is an concrete beam which is here supported and loaded. Then calculation is run, and I have some results in the console. So that's a typical starting point for us or for you to start the playing with the application that I already have a code which is working. I can work. All the dependencies are set, and also the packages. Here, for example, you can see here that we are using our Nugget package to work with it in the case that you will just start directly as you are used to with Visual Studio, that you are starting with the console application, and then you need to add some dependencies. You don't want to start with our template. You can do so, and then it's under the project. Here it's a manager for the Nugget packages, and if I will just search here, I can see that I have already installed the Dlubal RFM web service library. It's done by default by the template, or if I will just browse this, you can see here that I have listed three packages. Here is an arrow. That means that there are some updates of the library with some new advancement which I may use. So that's the typical scenario: how to start, how to use the template for a smooth start. That I don't need to think how it works. That I don't need to take care about the setting of the endpoints, creating the binding, and the first thing which is hidden under this region application settings, because that's what we have seen, that, well, we connected to the application, then we created a new model, and then we connected to a new model. That's one of the possible ways how to start, and that's good for the start for the modification. So I'll return back to the presentation, and also to the browser, because today we would like to speak about the generating of the windloads on the DOM with a circular base according to the Eurocode. Here we have an knowledge base article which served as an inspiration for it. Basically, it's generating of the wind acting on this structure, and we should receive something which look like this, some Mickey Mouse shape of the load. And here I'll close this one, and then I'll open what I have prepared. That's basically the same structure, and I'll go here just to start about some theoretical things in the meantime. So here I have a slide with inputs, what's given and what should be determined. So the given thing, that's an diameter of our cylinder. That means the cylindrical walls. Then there is some velocity pressure, and I have some reduction factor. My tool will calculate me the Reynolds number, external pressure coefficient, position of the stall, plus two other coefficients. Everything is taken from the Eurocode. What's quite difficult, it's quite, yeah, I may say difficult, is that I need to calculate the value of the load around the circumference of the cylinder, because it's variable as wind is variable around the circumference. And here are some equations which I need to use, and here are some results which I need to calculate. So if I will go back to the RFM, and I'll just start my example, which I have prepared based on the template. So normally, what I will do, delete everything except a few things which are useful for me. That's this part that's coming from the original template, and also the part relates into the main function with the connection to the application. There is a slight modification that I'm not creating the new model, but I'm connecting to the active one because I want to enrich the model with the load. So I need to access the active model. Here you can see the results. Why I'm showing the result is the fact that here I have the load defined, and as you can see, if I would like to do it, and I would like to do it, let's say, manually in the UI, it's quite demanding on the labor work that I can define the free rectangular load, but I need to define all the parameters into the table. That could be quite demanding, and I need to calculate it. I have an option to import it from an Excel, do the calculation, but you can imagine that it could be quite difficult for the changes. And if I'll do the change of the model, or if I would like to do something similar in the different model, it could be quite difficult. Therefore, there is a tool, or I want to create a tool which will do it for me. So I'll delete this. That's will be for us an empty state, or I can do it later on, and I will describe the steps which I need to follow. Centrally, I need to calculate some parameters. As I said, I have an velocity, pressure, the slenderness reduction factor as an input, and it will calculate me the things which I need to. One of my colleague already did it, and write some functions which I will just use for the development, and they are hidden on the top. That's for the calculation of the parameters of the load. As you can see, it's quite a lot of the equations, also with some interpolations in between. So that's what I have and what I need to do. So I would like to be able to select a surface, because that serves me for the calculation of the diameter, and then I need to be able to create a load. So here I've shown you that I already have a load. So my procedure is that I already have, or I'm starting with the model, and I create free rectangular load with the load distribution which is varying along the perimeter. So here I have some inputs, and I'm curious what or which functions, which web service operations I need to use. For that, it serves me something which is called boomerang. as a tool where I can quickly inspect the web service operations. Here I have ones which I need to. So here I'll just run that get active model. It returns me some URL, some endpoint where to connect, and then what I need to know. It's that I would like to apply some selection for the objects. So I'll do it in my application or in the RFM application. So I will select the surface, and then I'll connect to the active model, and then I'm curious about the selected objects. So here I run the get select objects, and I receive that, well, my selected object is the type surface, and the identification number is 2. So I'll disconnect from this. So that's what I'm doing in this part. So here I have an operation which returns me selected objects. Now I know that all selected objects, they have some type. I'm looking for the surface, and then I would like to know the identification number of the surface, and then I need to find a way how to know the diameter. I can do it very easily, because as I know that, well, the ID of the object of the surface is 2, then I can use the function get surface. So let me show you it quickly here. I'll just connect, and then I have an option for the surface. So it should be under the S in the button. So here I'll wait a couple of seconds, and then I can run the command and see the results. And then I'll do the same. Okay, so here I want to know the information about the surface number 2. I know the geometry type. What I'm interested, it's the boundary lines, because from the boundary lines I'll get an information about the radius, which is here, and it's equal to 4 meters. So that we are here, and we know the radius, and then here I can run the clear selection. That means that I'll do what I will do with the escape in the UI. Basically, that was some preparatory phase that I selected. That I selected the surface. I get an informations about the surface. I know the diameter, so I have already some basis for the calculation. I need to input some velocity pressure, some lambda coefficient, and then I'll just calculate the parameters. And now what's coming next? It's that I need to create the object for object for the free rectangular loads, and I can do the same, because here I know that under the load case number 1 I have the free rectangular loads number 1, and I'm curious about the structure of it, because I would like to fill it properly. So I'll just use my my tool for it, and here I'll ask for the free rectangular road. So I have the object. It's number 1 for the load case number 1. If I will run it here, I can see what I need to fill, that I need to add some load projection, load direction, load distribution, that I have some magnitude uniform for it, and so on. And that corresponds with the things which I'm doing here. That for the load direction from the enumeration, I'm using the load direction local, load distribution varying along a perimeter, and so on. So that's my way how I'm doing it, or how I'm building the tool, that I'm starting in the application, that I have some reference model or reference object. Then through the tool which I'm using, it could be any tool which is capable to work with the API, or here it's in the Microsoft Edge store as an add-on, that I can easily install it, easily use it, and it helps me to understand the structure of the object, what needs to be inputted, and how it should be. So I can play, I can quickly simulate during the development of the tool. I can quickly simulate the things to speed up, and it helps me to think about it. So we speak a lot about it. So I'll interrupt my connection, and then finally I'll delete the load. And here we are in the state that I have a model, and I want to generate the free rectangular loads, which should represent me the wind acting on the cylindrical shape of the wall. So in RFM in the application, I'll do the selection of the wall. I'll go to my tool, and then where we are starting here, run the tool. So how to easily do it? So I'll try to use this, and this. Okay. So here am I at the beginning. I'm connecting to the application. I should be connected. Now I'm asking the information from the application. For example, I want to be sure that I'm connected, to the right version, because in some versions some functions may miss, mainly in the older ones. And for example, I want to be sure that, well, my language of the UI is in English. So here am I. Now I'm connecting to the active model. Here I got the response that the URL of the model client, it's localhost and port 8082. So I'll connect, and then I'll ask the selection. On the background, you can see that the application is locked. That's done for the purpose, because now if I'm connected to a model, and then if I'll do some modifications in my tool, and simultaneously in the UI, I can corrupt the model or corrupt the data that the application will be waiting what's the right input, what's the wrong input. So therefore there is the locking. Here I can see that I already have some selection, that it's the surface, and with no or added identifier which is equal to 2. Here I have the for each for through the selection objects where I'm searching the surface. You may say, well, you select one surface. Why? If I will select the whole model, the whole scene, I'll get all the informations which are available. Therefore, there is a selection. And here I'm trying to find the diameter. By default, it's 0. So I'll ask information about the surface, which I have. Then I go through the boundary lines, and I'm searching for the line, which is on the bottom or on the top, because that's the type circle. And then I have an information from the line about the circle. I can calculate the diameter, and I know the center of the line of the type circle. So that I have it. So let's continue here. What I said, now I have information. I have my information stored in the objects, so I don't need to have the selection, so I can easily clear it. And now I have some safety check that, well, if diameter is not found, that means there is a wrong shape of the model or so. I can do it. Sorry, I'll just go back here. So here, there, and there. And then I have also the other informations. Now I'm asking about the value QP. So let it be 0.2. Then I'll continue. That it will ask me about the input of the reduction factor, which I will set as an 0.6. Here I have a calculated value, and here I have calculated value of the Reynolds number. And here that's the last step which I need to do, and that's a creation of the inputs for the rectangular. Oh, sorry, for the free rectangular loads. That I have some inputs, some rows here, that I have some angles where I'm calculating the values. It's a list of the values here in 0, 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, 165, and 180. So if I'll do it, I calculate, or the functions calculate the parameters. And once I have the calculated parameters, I can create the free rectangular load. That's everything which is here with the definition of the axis, start angle, load direction, and so on. Here you may notice that here is a property of the object which is called axis start angle, and below it's axis start angle specified. One, it's in this case it's a double parameter. Here it's the Boolean. It's therefore the object which is called free rectangular road can have dozens of properties, and we want to use just them which just minimum of the properties which we need to for the definition of the object. So if I want to input the property, I need to also specify that, well, I'm inputting this property. It's done for the reduction of the informations which are sent through the communication channel. So just to condense or to comprime the message which is sent between the application which we are running and RFM. So here we have an object which is called WLO, windload, and here I start with the setting of the object into the application. Here I have an function from the client model where I notify the RFM or the application that I'll do some modifications, that the signal be prepared, that there will be some modification. So it's in modification phase. Here I have an function for the setting of the freeload. So I send the information to the RFM. It replied with some code and so on, and then I have the finish modification that's saying, well, I finished my modification. Do all the checks, all the things which you need to check that the model is consistent. I inputted the values which are necessary, and nothing is missing. I have it here in the try catch finally for the purpose, because if something is wrong with the object for the free rectangular road, I can receive a fault string, which is then translated to the exception, which I can catch here. I can see the content. That's here. It's just for the setting of the object, and here I can have the same for the finish modification, that it could also return the so-called false string, which is then translated to the exception. That means that something is horribly wrong with the model. And I can also return it. Here you may notice that, well, if something wrong happened, I can cancel the modification. That means that the model and the data will be resetted into the state before the begin modification was called. So the same I could do also here. And as you may notice here, I was in the set free rectangular road, and then I did the finish, and here I have an result. So I'm at the end of my tool, and here if I will press any key, then I can go back to the application. And here, as you can see, I have the load with the calculated parameters, and then I can simply run the calculation, and I will receive the results from the load case, which is simulating the wind load acting on the Silker dome or dome with the Silker base. And what I can do, I can also check the values of the calculated calculated loads or load distribution in the X or in the Y axis. I'm at the end of my presentation and of my talk. Here is a link to the knowledge base article, which is describing how to do it in RFM 5, and it serves as an motivation how to do it, or how to create a nice tool for the calculation of the wind load, thanks to the web service technology. That was all from my side. I would like to thank you for your attention, and I'm hand over the speech back to Andreas.
Okay, Jaroslav, thank you for this nice presentation. I would like to take over the screen that I show some. Before I show you where you can find the recording and files and so on, I would like to say that you can book a free online appointment, such as a product demonstration, a personal free product demonstration, or you would like to get a not binding offer for any add-on or program from us, just contact our sales team with that link here, for example, or you can scan the QR code. I would like to show where you can find the PowerPoint slides. Just a moment. I open our website, dlubal.com. That's our website. And under news and events, you can find our webinars. That's today's webinar. That's the upcoming webinars. I would like to invite you to the webinar next week. I will present it, replication of standardized steel joints. Just register if you want to see the webinar. That's today's webinar. And in the next days, you will see the recording here. You will get a link with an email, and that's the direct link to that page here. There should be the recording. Here you can find the presentation slides and the files of today's webinar. Okay, when you leave the webinar, there is a small survey. It takes you only 1 minute. You can score the webinar. Just note that the worst score is 1 and the best score is 5. You can enter wishes for future webinars, for example. If you don't want to enter any wish, then you have to leave it empty or enter a sign, such as minus also, if you want. Okay, then I would like to say thank you for your attention. Thanks to Jaroslav for the nice presentation. Thanks to Dogukan and Frank for answering the questions. Have a nice rest of the day. Bye-bye.
Have a nice rest of the day. Bye.
Bye, everyone.